Hi everybody, welcome back. Today we are in section 3.5 and we're going to be talking about using the point-slope formula to write the point-slope form of a linear equation. And I'll also show you how to write the equation of a line when you're given 2 points on the line. And I'll also show you how to write the equation of a line that is parallel or perpendicular to a given line. So let's go ahead and get started. First of all, remember that in the last section, 3.4, we talked about the slope-intercept form of the line, and that is y equals mx plus b. And remember, it's called slope-intercept form because we can always see the slope, which is the number in the m position, and the y-intercept, which is the number in the b position. So that's how this got the name slope-intercept form. But there is another form of the line called the point-slope form. And it's called the point-slope form because when you look at that form, you can see the slope and one point that is on the line. So we can use this form to write the equation of any line where we know the slope and one point on the line. So here is the point-slope form of a linear equation with a slope m going through the point x1, y1. So the formula is y minus y sub 1 equals m times x minus x sub 1. Now remember, the m and the x sub 1 and the y sub 1 are all numbers that you will know. But the x and the y that don't have subscripts, those are going to remain in variable form. So let's just practice one here together. So this says write an equation of each line, give the final answer in slope-intercept form. So at the end, for this problem, at the end we will want to solve for y. And what I want you to remember is that every time the instructions say write the equation of a line, you can always start with the point-slope form. So here we have x1 and y1, and of course m. And now let's remember what the point-slope form looks like. Y minus y sub 1 equals m times x minus x sub 1. And what we'll do is just plug in our known values. So y minus y sub 1 is going to turn into y minus 4. M is negative 3. And x minus x sub 1 is going to become x minus negative 2. Okay, the first thing we can do is clear up this minus negative situation. So this should be written as plus. And then what we can do is distribute our negative 3. So that's going to give us y minus 4 equals negative 3x minus 6. Always be careful when you're distributing a negative, because notice that negative 3 times x made negative 3x, and negative 3 times positive 2 made negative 6. This right here is a source of a lot of mistakes for people. They'll notice that sign there and they'll put a plus. But you have to remember that you're multiplying everything by negative 3. So it's going to change the sign. And finally, to get this into slope-intercept form, all we need to do is add 4 to both sides. And so we're going to end up with y equals negative 3x minus 2. And let's try this one together. This one is the same idea, but we have a slope that is a fraction. Don't let that bother you. So again, we'll start by labeling our given values, and we'll go ahead and write down the formula just to keep that in mind. And so now we'll plug in our x sub 1, y sub 1, and m. So y minus y sub 1 equals m, which is 3/5, times x minus x sub 1. Now, we don't have to fix the minus negative here like we did in the last example, but we do have to decide here what to do with this 3/5. One thing you could do is multiply both sides by 5 to eliminate this denominator. It's not really necessary, and I'm going to just plow through without doing that, but if that fraction is really bothering you, you could do that. I am going to go ahead and just distribute the 3/5. So that's going to give us y minus 2 equals 3/5 x minus 3/5 times 4. Now we know how to multiply fractions, and this 4, although it's not a fraction, we could write its denominator as 4 over 1. So remember, when you multiply fractions, you do top times top and bottom times bottom. So 3/5 times negative 4 would be negative 12 over 5. Now, I've just copied that same result up here because now what I want to do to get this answer in slope-intercept form is I just want to add 2 to both sides. And that shouldn't be hard to do, but we can't really do it mentally as easily as we did in the last example because here we're adding a fraction plus 2. We have negative 12 fifths plus 2. So you might have to go over on the side of a piece of scratch paper and do this little fraction addition, or you could choose to do it on your calculator. Remember, when you're adding fractions, you need a common denominator. So the denominator for the first number is 5. So I need the plus 2 to have a denominator of 5. So I'll multiply that 2 by 5 over 5. That gives us negative 12 fifths plus 10 fifths, which adds up to negative 2 fifths. So we come out here with y equals 3 fifths x minus 2 fifths. And that is the final slope-intercept form of the equation of the line that goes through 4, 2 and has a slope of 3 fifths. Now let's talk about how to write the equation of a line when you're not given a slope and 1 point, but when you're given 2 points on the line. So we'll have to find our own slope. Now, before we do that, we're going to pause just a minute and notice that we have seen this form before where the x and the y are both on the left side of the equal mark and the constant is on the right side. This is called standard form. And not only do we have to have x and y on the left and the constant on the right, but also we can't have both the a and the b be 0. So we have to have at least an x term or at least a y term, usually both. Now your book points out, and I also want to call your attention to the fact that the definition of standard form is not exactly the same in all texts. They all have this in common, but they don't always have the next thing that I'm going to tell you, which is in this textbook, we will always write standard form equations so that the a, the b, and the c are all integers. In other words, they're not allowed to be fractions or decimals. They all have to be integers. And the a not only has to be an integer, but it also has to be positive. So basically, it has to be a whole number. It has to be 0 or more. Can't be negative, and it can't be a fraction. So here we have example 2, and it says write the equation of a line passing through the points 3, 4 and negative 2, 5. And notice that it says give the final answer in slope-intercept form and then in standard form. Now remember what I told you, whenever the instructions say write the equation of a line, you'll always start by pulling out that point-slope formula. So let's get a look at that formula again. Anytime the instructions say write the equation of a line, you'll start by thinking of this formula. Now what do you need in order to use this formula? Well, you have to know 1 point, x1, y1, and you also have to know a slope. Now in this problem we were not given 1 point and a slope, we were given 2 points. So we need to use the slope formula to find our own value for m. So let's call the 3, 4 x1, y1, and we'll call negative 2, 5 x2, y2. And let's remember the slope formula. Now I'm not going to write it here, but it's m equals y2 minus y1 over x2 minus x1. The slope formula is basically rise over run. It's the change in the y values divided by the change in the x values, and we find the change by subtracting. So the slope here is going to be difference in the y's, 5 minus 4, over difference in the x's, negative 2 minus 3. So in the top, 5 minus 4 gives us 1, and in the bottom, negative 2 minus 3 gives us negative 5. So here we have 1 over negative 5. And remember, whenever a fraction comes out with a negative in the denominator, we need to either move that negative to the front or to the top. We never leave it in the bottom because it's just confusing to write it that way. So we will think of our slope here as negative 1 over 5. And now we are ready to use the point slope formula. And the good news is that we can choose to use either point that looks convenient to us. All we need is the slope and 1 point, but we have 2 points, so we can choose which one we like. I'm going to use 3, 4, just so I don't have to deal with that negative there. So our point slope formula is going to say y minus 4 equals negative 1/5 times x minus 3. Okay, now just like in the last example, they have asked us to put the final answer in slope-intercept form, so we'll do that first, but then we'll also go ahead and transform it into standard form. Okay, so I'm going to do just like I did last time, and that is I'm going to distribute the negative 1/5. So negative 1/5 times x gives us that term, and negative 1/5 times negative 3 gives us plus 3/5. Okay, now I need to add 4 to both sides, and we'll have to do, again, this little fraction plus a whole number addition here. So I'm going to do that in blue because it's scratch work. So 3/5 plus 4, we need a common denominator, so I'll multiply this 4 by 5/5, and that's going to become 3/5 plus 20/5, so we get a total of 23/5. So that means that after adding 4 to both sides here, we have y equals negative 1/5 x plus 23/5, and that is our slope-intercept form. Now, they also asked us to get the equation in standard form. So remember, standard form is ax plus by equals c. In other words, we need the x and the y on the same side of the equal mark, we need the constant on the right side, and we need to eliminate these denominators. So we'll start here by multiplying both sides by 5. I'm going to multiply every term by 5, and let's see what happens. This denominator is going to cancel out, and this denominator is going to cancel out, and that's going to leave us 5y equals negative 1x plus 23. And finally, to get to standard form, I just need to add x to both sides. So plus x here means I'm going to end up with x plus 5y equals 23. And so that's our final standard form. Okay, now here is a practice one for you to do that's very similar to the one we just did. So I would encourage you to pause the video here and try this one by yourself, and then you can check the answer with me at the end. All right, now I'm going to just step through it with you in case you need to see how it goes. So it says write the equation of a line passing through these 2 points. Because it says write the equation of a line, I know that I need to start by thinking about my point slope formula. And I need to know one point on the line and a slope. I was not given a slope, so I'll have to use these 2 points to calculate my own slope. So I'm going to label these 2 points as x1, y1 and x2, y2. And so now the slope will be m equals 4 minus 1 over 2 minus negative 3. y2 minus y1 over x2 minus x1. And so in the top, 4 minus 1 is 3. In the bottom, 2 minus negative 3 is 2 plus 3, which is 5. So our slope is 3/5. All right, now I can plug that slope and either point into my formula, and I'm going to choose the 2, 4 because it doesn't involve any negatives. So now I'm going to have y minus 4 equals 3/5 times x minus 2. And to get to slope-intercept form, I'll need to distribute this 3/5 and add 4 to both sides. So I'm going to start here by distributing 3/5. 3/5 times x gives us 3/5 x. 3/5 times negative 2 gives us negative 6/5. And now I will add 4 to both sides. So because this is a fraction plus a whole number, I really can't do it mentally, but I'll just come over here and jot it down as scratch work. So negative 6/5 plus 4, I'll need a common denominator, so I multiply that 4 by 5/5. That gives me negative 6/5 plus 20/5. Negative 6 plus 20 is positive 14. So I end up here with positive 14/5. So now I have as my slope-intercept form y equals 3/5 x plus 14/5. And that is our slope-intercept form. Now we need to get this into standard form, so I'm just going to copy it again here. And I know that in standard form I have to have these denominators eliminated, so I'm going to start by multiplying everything by 5. It's okay to do that as long as we do the same thing to both sides. So I've multiplied everything on the left by 5 and everything on the right by 5. Now this 5 is going to cancel this one, and these 2 5s are going to cancel each other. And we're going to end up with 5y equals 3x plus 14. And this is almost standard form, but I need the x term on the left. So I'm going to subtract 3x from both sides. And now again, this is closer because now I have the x and the y on the left and the constant on the right, but I need the a number to be positive. So now I'm going to multiply through by -1. So I've multiplied everything on the left by -1 and everything on the right by -1. And now we end up with 3x minus 5y equals -14. And that is our standard form. So again, here we have slope-intercept form and standard form. Okay, now think about all the different forms of linear equations that we have looked at. We have seen the slope-intercept form, which is y equals mx plus b. And they call it that because when you look at it, you can see the slope and the y-intercept. We have seen the point-slope form, and that's y minus y1 equals m times x minus x1. And they call it point-slope because when you look at it, you can see a point, the x1 comma y1, and the slope. And we have also seen the standard form, which is ax plus by equals c, where the a, the b, and the c are all integers, and the a has to be positive. Now, any one form can be converted to any other form as long as you know what the forms look like, and you can do that depending on what the situation requires. Now let's move on and talk about how to write the equation of a line that is parallel or perpendicular to a given line. We saw in section 3.3 that parallel lines have slopes that are equal to each other, and perpendicular lines have slopes that are opposite reciprocals from each other. So one will be positive and the other will be negative, and they will be reciprocals. So what we're going to do now is take that little bit of information and put it together with what we've done earlier in this section using the point-slope formula. So this example says, write an equation of a line passing through the point -3, 6 that satisfies the given condition. So we'll have a part A and a part B. The condition for part A is that our new line needs to be parallel to the line 2x plus 3y equals 6. Okay, how do you know if two lines are parallel? Well, of course, if they're parallel, they have the same slope. So in order to know that the new line is going to be parallel to this line, we'll have to make sure that they have the same slope. So we need to find out what the slope of this line is. So we'll start by putting this line in slope-intercept form so that we can see its slope. So let's solve it for y. So the first thing we'll do is isolate the y term. We'll move the 2x to the right side of the equation. And now we'll isolate the y variable, so we'll divide through by 3. And we see this line in slope-intercept form is y equals -2/3 x plus 2, because 6/3 reduces to 2. Now, the y-intercept is not important here at all. All that matters to us about this line is its slope. And what is its slope? The slope of this line is -2/3. Okay? So that tells me that the new line needs to have a slope of -2/3 as well. Now the new line needs to have this slope and it needs to go through this point. So this is where I can use my point-slope formula. So we'll say y minus the y that we know, which is 6, equals m times x minus the x that we know, which is -3. So this is the point-slope form, but we need to clear up this little confusion here. Minus -3 is really better written as +3. Okay, now notice that it says give final answer in slope-intercept form. So we'll need to convert this to slope-intercept form. In other words, we need to solve for y. So we'll start by distributing the -2/3. That's going to give us y minus 6 equals -2/3 x minus 6/3. So -2 times 3 was -6, and then 3 times 1 was 3. Of course, right off the bat, you see that 6/3 reduces to 2. So let's go ahead and do that. And now let's just add 6 to both sides. And we have y equals -2/3 x plus 4. And that is the slope-intercept form of a line that is parallel to this line and goes through this point. For part B, let's try a perpendicular one. So this one says that we want the equation of a line that goes through negative 3 comma 6 and is perpendicular to 2x plus 3y equals 6. Now this is the same line that we were working with in part A, so I won't solve it again. I've just gone ahead and copied that here where we found the slope of that given line. This is the same work we did on the previous slide. But now, in order to be perpendicular to this line, we need the slope of our new line to be the opposite reciprocal to negative 2/3. So the opposite reciprocal means our new slope will be positive 3/2. Change the sign, flip the number, and our new slope is positive 3/2. And so now we're ready to plug into our point slope formula. Y minus 6 equals our new slope times x minus negative 3. Again, minus negative changes to plus. And in order to get this into slope-intercept form, we'll have to distribute the 3/2. And so I did 3/2 times x and got that. 3/2 times 3 and got 9/2. And now I need to add 6 to both sides. Of course, 9/2 plus 6 is hard to do mentally, but it's not hard to do if you jot it down. We'll do 9/2 plus 6. We need a common denominator, so multiply that 6 by 2/2. That gives us 9/2 plus 12/2. And 9 plus 12 is 21, so we have 21/2 here. 9/2 plus 6 is 21/2. And so now we have y equals 3/2 x plus 21/2, and that is our final slope-intercept form for a line that is perpendicular to this line and goes through this point. And here I have a practice example for you with a part A and a part B. Pause the video and try each one on your own and then check answers with me. Okay, here we go together. In order to get our new line to be parallel to this line, I need to know this line's slope. So I will solve this equation for y. So I start out by moving the 2x to the right side. That gives us negative 3y equals negative 2x plus 10. Now in order to isolate the y, we'll divide everything by negative 3, and that will give us y equals 2/3 x minus 10/3. And so we now see that the slope of this line is 2/3. We want the new line to be parallel to this line. So if the slope of this line is 2/3, the slope of the new line also needs to be 2/3. And so now we have a slope and a point, and we can use our point slope formula. So y minus the y that we know equals m times x minus the x that we know. Minus negative 8, of course, becomes positive 8. And now we'll distribute that 2/3. 2/3 times x is 2/3 x, and 2/3 times 8 is 16/3. Top times top, bottom times bottom. And now we just need to add 3 to both sides. 16/3 plus 3, if we get a common denominator, will become 16/3 plus 9/3, and 16 plus 9 is 25. So we have 25/3 here. And our final slope-intercept form for this new line is y equals 2/3 x plus 25/3. Okay, part B, for you to try on your own. Remember to pause the video and try it by yourself and then check. Okay, again, we were given the same equation that we worked with in part A, and we've already found the slope of this line, so I've just gone ahead and copied that here. We know that this line has a slope of 2/3. Now the new line needs to be perpendicular to that. So the new line will have to have a slope of negative 3/2. All right, now we go ahead with our point slope formula. So y minus the y that we know equals our new slope times x minus the x that we know. So we have x minus negative 8. Now the first thing we always do is clean up that minus negative if we have it. So that makes x plus 8. So now I have y minus 3 equals negative 3/2 times x plus 8. And I'm going to distribute the negative 3/2. So that's going to give us y minus 3 equals negative 3/2 x minus 24/2, because negative 3 times 8 would be negative 24, and 2/1 would be 2. And of course 24/2 reduces to a whole number, so why not do that? Y minus 3 then equals negative 3/2 x minus 12. 24 divided by 2 is 12. And all I have to do now is add 3 to both sides, and then y equals negative 3/2 x minus 9, because negative 12 plus 3 is negative 9. And that is our final slope-intercept form for this line. Okay, I hope that if you haven't gotten anything else out of this section, that you have figured out that you need to have the point-slope formula memorized because you use it so often. And if you have it memorized and you have it ready to use, it'll make all of these problems so much easier. And other than that, you just need a little practice. So make sure and do that when you're doing your homework. Practice using the formula from memory. Don't look at it in your notes every time. Practice, see if you can recall it on your own, and that way it will stick with you and you'll be able to do it really easily on tests. These problems that we did in this section should be some of the easiest ones on any test that you take if you have done enough practice. So good luck. See you in the next section.